Hello everyone, welcome in. Welcome to Intro to Programming in Java. For folks who need to access the slides, they are available in the Canvas files. Just a quick thing here. So slides over here, and then there should be the slides over here. So yeah, feel free to load these up. It's going to be useful because there's going to be some links, some clickable things. Okay. So once you have the slides loaded up, let's go ahead and start. Cool, welcome in everybody. I'm going to start off with a bit of introduction and then motivate what computer science can entail. And then we'll do some technical things like setting up a development environment. And then we'll end off the class with some hands-on terminal commands. And then this is going to consist of something called Hello World. A hello world, you can think of it as an analogy to make sure that our development environment is set up correctly. I did record some separate videos just in case folks want to look at some more detail on how to do these. So yeah, feel free to take a look at these in a bit. I'll refer to these later. But yeah, this setting up development environment, this is a short 10-minute video. And then the hands-on terminal commands, this is going to be a 30-minute video. It just goes into a little more detail on what we're talking about. Okay, I'll talk about what this 1.2 means later. This is suggested readings. So I'll talk about the readings later when we pull up the syllabus. All right, let's get started. Just introduce myself. My name is Andrew Tack. I'm from a few hours away. I grew up in Yosemite. Let's see, I started off in Cabrillo and then went off to UCSC. I got a couple degrees there. Both of them were in computer science. The master's was concentrated in AI. All right. Current hobbies. It's pretty much making things work the way you want to. So building computers, programming automated tools. This is really fun stuff for me. I like modifying things and making them work to my liking. Nowadays, it's pretty hard to have full control over your devices. So yeah, this is one of my hobbies. Having full control over your devices, your software, and defining how they actually work. That's pretty much my hobbies. Okay, let's see. Let's go over syllabus tour real quick. So I got the syllabus over here, over in the Canvas. It should be on the home page. Okay, here's our syllabus. It starts off with a calendar for folks who want to catch me on campus. These are the times that I'm on campus. So yeah, feel free to take a look through this. There's also a table here that describes these times. This is a high flex class, meaning that it's going to be live on Zoom. It's going to be recorded to YouTube, and I'll also be available in person. All right. My office hours are every weekday. I'm in the STEM center every weekday. So yeah, you can catch me there. If you'd like to go to a Zoom appointment, feel free. Just contact me and then we'll schedule something. I'd be happy to schedule it during my STEM office hours or during one of these gaps over here. So yeah, feel free to let me know. I'd be happy to accommodate. Okay, there's going to be a weekly schedule here. I'm going to click on this every lecture. This is subject to change because we might be ahead of schedule or behind schedule, so things might shift around. But generally, we can see our weekly schedule here. The first week is going to consist of just a little bit of intro, and then the meat of this will be setting up our development environment and then doing a hello world program. All right. There are some suggested readings here. I'll talk more on this in a bit. And then nearly every week, there's going to be a project. All right. So let's scroll down. The grading here just consists of 3 things. We have projects. That's where most of the weight is. We have the labs. We'll talk about this in a bit. And then 2 exams. We've got a midterm and a final. All right. As for the projects, Every week, we're going to be applying what we just learned on a coding project. Okay. The labs, this is kind of like a free form activity. In the past, in the past versions of this class, the labs would be assigned reading and assigned exercises. But this time, we're gonna have a little more freeform because some people learn a little differently. Lab time is a way of folks to explore content that will help you out with this class. I highly suggest reading supplementary material. Every week, I'll suggest some readings that folks can look at. You can interact with small program activities. Maybe you're coding some small programs and practicing your programming skills. So that this would be considered lab time. Maybe you're watching supplementary videos from an external source. Whatever your best style of learning is can be applied to these labs. Okay, you'll see more detail on this in the assignments. Okay. Speaking about the labs, I did suggest there's going to be some supplementary material. So this class doesn't have an official assigned textbook, but I do recommend this online content over here. In particular, there's this online course. It's free. It's from the University of Helsinki, and you can access it with this link over here. So let me just check this out. Our course will be covering Java Programming 1. This is the part 1 all the way to 7. So yeah, feel free to look through this. Every week I'm going to be suggesting a certain section. Like for this week, we're going to be looking at 1.2 and then a few more others. You'll hear about this on Wednesday. Okay, so yeah, these are suggested readings. If you're more of a hardcover textbook person, there are some official textbooks that you can use as well. I believe these are available in the Cabrillo College Library, so you can feel free to check these books out if hardcovers are your way. I did, when I learned programming, it was learning from a textbook. So yeah, some people might be that way too. Okay, other resources. Sometimes you might want to visit some tutors. If you can't make it to my office hours, or maybe the schedule doesn't work out, there's also tutors in the STEM Center and the CTC. I am in the STEM Center every weekday. You can check out my schedule for that. There are tutors in the STEM Center as well. There's chemistry, biology, math, physics, computer science as well. They're all available there. So I think they have some online help as well, but I think they mainly have in-person tutors. The CTC is the same way. CTC stands for Computer Technology Center. They have Lender laptops. They have a lot of computers you can use, and they have tutors there as well. The tutors there have probably taken my class before, so they'll be able to help out with your content as well. So yeah, always feel free to reach out, give the tutors something to do, or come to my office hours as well. Okay, there's the Accessibility Support Center as well, so feel free to go there. As for contact info, you can email me. I would probably prefer an email instead of Canvas message, because emails have a little nicer format. The Canvas doesn't really format things nicely. But yeah, either way it works. If anything, technical questions should be asked on the discussion forum. We have a discussion forum over here on the top left. Technical questions are things like maybe you're having trouble understanding a certain concept in the material, or maybe you're having some sort of error in your code. It would be a good idea to ask these in the discussion forum. The reason is so other peers can see it too. Your classmates might have the same exact question, so putting it publicly in discussion form would be super helpful. If you ask me privately, I'm most likely just gonna copy it and then paste it into the discussion forum and then answer it there. But yeah, you should contact me if there's any private matters, like maybe you want to talk about grades or other things that shouldn't be public. So yeah, feel free to reach out. I'm available. Okay, that's it for the syllabus. Let's move on. All right, I want to start off with a quick motivation. Some folks this is probably your first programming class, so let's talk about some motivating things that this field entails. So computer science spans diverse areas. There's so many areas that it touches. Almost every field has some sort of technical computer science involved in it. So I'm just going to cover a few of them. Nowadays, data science is kind of a trendy topic. AI, actually. AI is a very trendy topic nowadays. This diagram will kind of show the overlaps between it. Here we are studying computer science. So we're going to be touching a bit of each of these things. We'll be touching a bit on statistics, some things on data science, and maybe some things in AI. But yeah, this is a very trendy topic nowadays. I see it as an umbrella term. A lot of people refer to AI as large language models like ChatGPT or any of those other services where it's like a chat bot. You talk to it and then it'll generate some text back to you. So that's kind of what most people refer to it as. But AI also refers to multiple things, like algorithms that represent autonomous vehicles, reinforcement learning. This is like a technique. Reinforcement learning is like a technique that trains an agent to get better and better through repetition. We have image recognition. This is another. We also have a lot of prediction models too. A lot of prediction models can be considered underneath the AI umbrella. Prediction means to kind of make a guess on what the future can be. So that's some useful stuff. We got recommendation engines for folks who have some sort of social media. Maybe you have Instagram or TikTok. Those things are running recommendation engines, which is like a form of AI, a form of AI that uses your info and predicts what your behavior could be. And they do that to recommend more relevant content to customers. So yeah, AI is everywhere. It's a very trendy topic. This was one of my concentrations in grad school. So yeah, always feel free to let me know if you're interested in this stuff. Some really cool stuff. Okay, what else does computer science entail? Some other topics like game programming. Some folks might be interested in creating their own games. Maybe they want to modify some games. Computer science will help you out with that. So maybe AI too, game AI. I did some of this stuff in my undergrad. Some fun stuff. Game AI is like programming agents to maybe play a game for you. So you can automate things to play for you. It's pretty cool. Okay. Computer science also touches full stack development. This is the combination of front end and back end. In particular, talking about creating websites and services that run on that website. The front ender would be working on the user interface, making the buttons look nice, making sure they click correctly, just making sure the user is able to navigate seamlessly. And then as for the back end, this is the person that maintains a server, makes sure the data is all fair, and making sure that the front ender can do their job. So yeah, full stack development aims to combine these two things, which is a big part of computer science, creating user interface and making sure the server stuff is working in the back. All right. Folks might be also interested in information technology. So there's a department here called Computer and Information Systems. This is a CIS. For folks who have taken a CIS class, maybe you have seen this data center here. I believe this is a data center at Cabrillo. I think this is at the CTC. Yeah, this is the data center at the CTC, I believe. And they're pretty much doing some hands-on maintaining servers and data centers. So yeah, maybe you're interested in this stuff. Computer science would be a good intro to this. All right. What else? Robotics. Some people might be interested in using hardware and programming that hardware to work in some way you want. I used to teach a class on this called CS-12J. This was a class that uses C++ to program hardware. So yeah, feel free to let me know if you're interested in this as a hobby. It was pretty fun stuff. Okay. People might be interested in money. So these technical jobs, I believe this is the median annual salaries in the whole nation. If I were to take the data in for like 100-mile radius or California, these numbers would probably be higher. So yeah, there's a lot of money in these technical jobs. Okay, so yeah, computer science, there's a lot of things you can do in it. Some meta skills that we'll gain from this course. These are kind of like life skills that we'll gain if you're doing things kind of legit and actually trying to understand the material. So some skills we'll gain is problem solving. This is we'll be introduced some problems, and then we'll have to think of some way of solving it, which leads us to algorithmic thinking. This is probably one of the challenges in the class, actually. Algorithmic thinking is like a way of organizing statements, or a way of organizing your thoughts into a way where the computer can execute certain things. The algorithms aim to solve a certain problem. So yeah, we'll talk about algorithmic thinking soon, and do some creative exploration. Creative exploration, it's kind of a synonym with maybe troubleshooting or critical thinking. These are, you can imagine it as maybe your program is failing and you'd have to explore ways on troubleshooting it. So if you're taking a computer science programming course, it's likely you're going to gain a lot of these skills. Okay, let's carry on. I am running a program that helps pipeline people into UCSC research labs. If folks are interested in research or university or grad school, or getting in touch with professors at the UCs, feel free to let me know. I'm working with 2 professors right now at UCSC, and every semester we pipeline students into their labs. So some students want to have more on their resume, or they want to get exposed to higher level education. So let me know if you're interested in this program. We'll get you all signed up. It's like 1 hour a week for 4 weeks, 4 or 5 weeks, I believe. Okay, let's let's move on. Okay, let's talk about a little CS history, and then we'll move on to the actual technical stuff of today. So a bit of history on computer science. A computer used to be defined as an occupation, like a position in the job. For example, here on this wiki, scrolling down here a bit, these are some human computers working on something. They're most likely performing calculations to contribute to a war, I believe. Let's see, this is called a NACA computer. So this is a human working with a microscope and a calculator. So yeah, computer. We used to be an occupation. Fast forward to later on. One of the first programmable computers, the electronic, took up the space of a whole room. This was in the 1945. A computer was this big, took up a whole room. Okay, and then fast forward to now. We have a lot of us maybe think of computer as an AI now, but the overall pattern here, computers perform calculations. So as computer scientists, we're going to be designing algorithms that calculate certain things. So yeah, hopefully people are kind of getting a sense on the history. Okay, let's move on to the meat of today. This is the part where you can refer to a separately recorded video. I'm aware that some folks already have this set up. If you don't have this set up already, please feel free to take a look at this video. I'm gonna go over it briefly, but the video will talk about installing a development environment. So you can check this out in two ways. It's usually in the slides on the very top. So on the very top in the slides, there's a link to a YouTube video. This is a short 10-minute one. You can take a look at it. Or you can visit this on the YouTube playlist. The YouTube playlist can be accessed on the Canvas. And then scroll down to there's a link over here below the calendar. The YouTube playlist, it's gonna contain the videos, in particular this 10-minute one I'm talking about. So yeah, feel free to take a look at this. It's gonna get a little more straight to the point. But here I'm gonna give a quick overview on what a development environment is. This is a set of software that we're going to use in our class. In particular, there's something called a graphical user interface. This is like a program that you can interact with using the mouse or keyboard. We'll also see a command line interface. This is, you can think of this as like a terminal where you type in commands, and those commands would control your computer. It'll maybe navigate around and help you out develop software. So yeah, we'll see two things today. Depending on your computer, the installation of the development will vary slightly, but it should be more or less the same. Most people are probably running Windows or Mac. So in the video all the way up here, it's gonna talk about it, how to install certain things. So I'll talk about this in just a bit. But yeah, this class should be general enough where any of these operating systems should work. Okay, let's talk about what the software stack that I would recommend. In this class, we will need to use a code editor. This is a program that allows us to write text, in particular source code. So this is meant for humans to type into. In this class, I recommend using something called VS Code. I'll have some links in the next slides for this. But yeah, VS Code is a text editor. We would write code, and then we'd have to run the program. So this is where we need to use a terminal. the terminal will allow us to run the program, but there's some steps in between. We do have to in Java. Java is one of those languages where we need to compile it. Compile means to convert this text file into something that the hardware can read. So the compiler is a program. It translates your human readable code into machine code. The reason we need to do that is because the computer hardware runs machine code like a binary. So it doesn't really run human readable text. That's why we have the compiler. It converts the human readable text into machine code binary, kind of. So yeah, this is what our development environment will look like. All right, let's talk about the suggested software stack. For the code editor, this class I recommend using VS Code. This is good for starters. It's a graphical user interface. It's got things you can click on. So yeah, I'll have links on this in just a bit. Finally, the Java Development Kit, or JDK for short. We'll be using JDK 25. This is one of the newer versions. It came out, I think, last year, and it's got a lot of nice functionality. So yeah, JDK. Let's see, VS Code. Let's see. I'm gonna actually skip over this VS Code. I don't want to repeat information, but yeah, you can install VS Code. This is once again, I do have a tutorial in the short 10 minutes over here, so you could take a look at that. But yeah, VS Code should be seamless. Download and then install. As for the JDK, this is gonna be a little more. JDK, it's a kit. It contains a lot of tools. One of the tools is a compiler. Once again, the compiler will, what's it called? It'll translate our source code. So if anything, when you download the JDK 25, I recommend a certain file. So just make sure you click on the right operating system here. If you're on Mac, I recommend downloading the DMG file. So take a look at the end of the link, and then if it says .dmg, I would recommend this one. It's actually the same. These two are pretty much the same, but the second one is a little easier to install. Now, the reason why is because this first one is a zipped file, so you'll have to unzip it. It's an extra step. But yeah, go ahead and download the second one because it's more seamless. Just download it and then double click it, and it should install your Java. I do want to mention that if you have an older MacBook, it's going to be these last two over here. You'll download this one. The older MacBooks, generally I'm talking about the ones with the Intel architecture, or if you're not sure, you could look at the back of your MacBook. If it has a light up Apple logo, I believe those are the older MacBooks. So yeah, once again, if your MacBook has a light Apple logo, if it has that, you're probably gonna have to download this x64 over here. x64 represents a computer architecture. If you have the newer MacBooks, like if you have like an M1 chip or M2, M something, if you're not sure what chip you're using, you can look at the back of your MacBook, and if the Apple logo doesn't light up, it's probably this newer one here. The newer MacBooks, Apple got rid of the light logo. Okay, Cool. So yeah, that's the Mac right here. For Windows, you're gonna want to download this over here, this exe. So this exe, these are pretty much all the same. It's just that this second one, it's a little easier. Exe stands for executable. So all you have to do is download this and then install it. It's like a 2-click process. Okay. Cool. So that's a pretty brief thing. Yeah, so once you have VS Code and JDK installed, let's go ahead and verify that it's all set up. So yeah, there's a couple ways we can verify. You can generally you can just pull up a terminal and then type in Java to see if it works. So I'm gonna pull up my terminal. On Windows, there's something called PowerShell. This is one of their terminals or consoles. On Mac OS, you can search terminal, and it should give you some sort of console here. So yeah, this is a terminal. It is a way of interfacing with our computer, but we can control our computer from here. And in particular, we're just going to use Java and see if it exists. So I'm going to type in Java space -- version. This is saying, hey, run Java program, but tell us what the version is. So I'll press enter here. And yeah, it looks like I'm running the right. It looks like it was good. If it didn't go well, you'll probably get an error message. So let me know if you get an error message, and I'll take a look at it. Okay, cool. So we got that. You can also verify in VS Code as well. So in Visual Studio Code, let me see. Let me restart this. In VS Code, there's a terminal button on the top left. It's the same. It's representing, for me on Windows, this is representing the PowerShell. So I can type in the same exact thing, Java -- version, and same thing. Your Mac should be the same too. Okay, so yeah, once you're all verified, we are ready. Okay. Okay. Yeah, once again, there is a video on this. Apologies if I repeated some information. Okay, but the video goes more in depth. I just separated it just in case people already have it done. All right. Okay, let's move on to the next part of this class. So one of our goals today was to set up a development environment. We just did that and verified it. Finally, there's going to be some hands-on terminal commands. This is a this is a final separate video. So this separate video is 30 minutes long. It's gonna cover a bit of terminal commands. So yeah, I would highly recommend looking through this. But if all went well, we're going to end up with a resulting workflow that looks like a text editor. This is VS Code, and then a terminal on the bottom, which allows us to interact with our program. Okay, cool. So let me back out real quick. Okay, so here's a hands-on activity. Okay, yeah, I did separately record this. So this is the 30-minute video I was mentioning it earlier. Please take a look at it. It's gonna cover a bit of basic terminal commands and how to use your development environment. Yeah, so go ahead and view this. Let me see. That video is gonna cover this stuff here. Okay, cool. And then once you finish that video, you should end up with you should end up with a hello world. So let me load up my hello world here. So in VS Code, I'm gonna go ahead and open up this file explorer and navigate VS Code to the CS-12J folder. So my CS-12J folder is here in the downloads. Okay, and then I have a leftover program from earlier. All right, let's see. Cool, yeah, so if all went well, then you should be able to run this program. So I do have to change my terminal into the correct working directory because this terminal is in the outer directory. It's in the CS-12J, like a root folder kind of, but now we need to dive into examples. Otherwise, we would get an error. Like if you try to compile and run your program, Java hello.java, you'll get an error because the terminal is not in the correct working directory. So let me go ahead and cd into it, cd into the examples. This changes into it. So change, there we go. Now we're inside of it, and then we should be able to compile and run. Okay, so this does do two things, by the way. I'm just going to explain this command real quick. Typing in Java, this runs your JDK that you just installed, and then this next one, hello.java, this is like the input file. So we're sending this file into the JDK, and it's going to do two things. It's going to compile and then run. So we'll talk about the differences in just a bit. I'm probably in a few weeks. But yeah, let's go ahead and compile and run it. And there we go. We get hello world. How are you? Cool. All right. Sometimes you might get compiler errors. Compiler errors are like it's the Java program telling you that something is wrong with your code. So if I were to make a typo here, like let's say I forgot a semicolon here. Let me just backspace this semicolon, and then let me save this so I can rerun it. I'll go ahead and save. Control S. Boom. Okay, I saved it. And then let me rerun this. So, oh, by the way, you can press up and down on the keyboard. This is gonna go through your history of commands. So let me go ahead and run this again. Java hello.java. Enter. And then here we go. This is an error message from the compiler. The compiler is saying, hey, we have an error on line 4. And in this case, it is correct. It says expected semicolon. So we just need to put a semicolon here, and that's gonna fix it. So I'll talk about syntax in the future. In a couple of days, we'll talk about syntax, which defines the formal rules to use a language. We'll talk about that in a bit. The whole goal of this is just to make sure people are familiar with the development process. The development process is over is this right here. So we would write code and then save it, and then finally we would test it. Test it consists of compiling it and then running. So that's the pipeline of development in this class. So let me go ahead and fix this. Fix and then rerun. Yeah, there we go. Program is working. Okay. Okay, let's see. Okay. So yeah, we're almost done for now. If anything, I do want to mention some things you might run into when you're reading supplemental material. We are using the JDK 25. The JDK 25 is a version of the kit, and it came out very recently. I believe it came out last year. It's a very recent, and I think it's a major update to Java. Our Hello World program looks like this. But in the previous versions of JDK, it was a little uglier. So this is another version of Hello World. It does the same exact thing, but it is a little harder to read because of all these other these keywords that you're not sure what's going on. But it is backwards compatible. We are able to run this code on the newer JDK as well. So let me just prove that. So I'll copy this over here and then go ahead and paste it here. I'm going to replace this main. Let me replace this and paste. Okay, cool. Yeah, this is going to do the same thing. Let me save it. So I saved, and then let me rerun it. Recompile and then rerun. Okay, enter. And yeah, you see how it pretty much does the same thing. It's like a couple of different styles. The reason why I'm going to stick with this second one is because it's a little easier to understand, and we don't have to talk about all of the other words. Like here in the old version of Java, there's a lot of confusion. Like oh, what is public? What is class? What's static? You know, what's all of these things over here? What's system.out? This is there's a lot of overhead happening. So I'm actually pretty glad that JDK 25 has some nice functionality that makes it easier for us to learn. So I'm pretty much saying that when you're reading supplemental material, you're probably going to get exposed to pre-25 things. For example, if I were to look at the recommended readings for today, so the recommended readings for this material is 1.2. 1.2. This I'm referring to the online Java content from this university over here. So this is the one I would mostly suggest. And if you check out 1.2 over here, so part 1, and then point 2, so printing. If you're reading like from a textbook or any other resources, they might not be up to date yet, but it still works though. Still works. This is a hello world statement. It's the same. It's the same as this over here. So let me revert this. Okay, I just Control Z to revert all of this. So it's the same thing. If I were to do a system print line and then hello world, these two lines do the same exact things. As we'll see in programming, there's like an infinite amount of ways to do the same task. So let me go ahead and save this and rerun it. Okay, rerun, and yeah, you see how those both statements are doing the same thing. So yeah, hopefully people are okay with that. When you're going through textbooks or other resources, they're going to be using this less modern style. We will have to use this style in the future though. When we talk about object-oriented programming, we're gonna have to change our style a tiny bit, but it should come together in a bit. Okay, so yeah, let's summarize that here. Okay, so yeah, before JDK 25, the hello world was kind of bloated, and it made things hard for the beginner programmer. But now we have JDK 25, and they inserted some functionality that makes it easier for beginners to understand. So yeah, I'll talk about all of these in a bit. We'll explain, what IO means, what this period is, what these parentheses do, and all these semicolons and stuff. This is syntax we'll cover later. I do want to mention that the first half of this class is gonna feel like grammar school. The first half of this class, let me check out this weekly schedule. All right, first half of this class, this is an intro class, so we're gonna be talking about fundamental building blocks and syntax. Syntax is defined as like formal rules in order to use a certain language. So yeah, the first half of the class is gonna feel like grammar school, but then after spring break, we're gonna be finally putting things together, and it should be some pretty fun stuff because there's gonna be some nice topics. Like I think people might like the visual programming topic. This is where we'll be using Java to create like graphical user interfaces. Maybe you might want to create your own game that has graphics in there, or maybe you want to create like a Minecraft mod. Someone did that before in my previous class, and they used it for their final project. So yeah, that's pretty much it for today. The whole goal of today was to set up, motivate and introduce, because this might be your first computer science class, and then we set up our development environment. If you didn't set it up yet, there's a quick 10-minute video, and then there's a longer video down here. I highly recommend taking a look through it. It's going to give you some hands on the terminal and navigating your computers. Okay, and then for this content, I suggest reading the 1.2. 1.2 is in the over here. Let me load it up again. Over here, the online content and Java programming. Okay, so 1.2 is over here. They talk about printing. Great. There are going to be some exercises as well. I would highly suggest doing them because it'll expose you to small interactive exercises that will help you put together things later. It looks like I do have to log in to see the exercise. This is free. If you don't want to use your own email, you can use your Cabrillo student email. Every Cabrillo student has a Cabrillo Gmail, so feel free to let me know if you want to access it, if you need to access it. But yeah, if you log in, let me log in real quick. If you log in, you're able to see some practice problems. For example, this one is saying exercise has the following code. Let's see, add a new line below the line comment. Okay, and it should print this. The output of the program should be Ada Lovelace. Cool, so this is a fill in the blank problem. The blank is right over here. That this is a comment. We'll talk about this in a bit. What's a comment? A comment is pretty much a way of documenting your code. It doesn't really run. So yeah, this is a good practice problem. If you wanted to practice this, I would probably do it on your local machine. For example, let me see. I guess I'll make a new folder here to be a little more organized. I'm gonna make a folder called like practice problems or something. So let me go ahead and create something called practice problems. Okay, so there, I just made a new folder, not a file. So this is a folder, and then inside of it, I'm gonna create a file. I'll call it like printing.java. Printing.java. Okay, there it is. Here's our empty text file. I'm attempting to do this problem over here. So this is a fill in the blank. You could copy this over and then fill it in. The blank is right here. Let me resize. Okay. You don't have to worry about this stuff over here. This is just a boilerplate. A boilerplate means you can ignore it because we'll learn it later. Or if you want, you can get rid of this and just use the new style. Let's see. So you could just do the void main style. But this is the JDK. You could do void main, and then the point of this exercise is to print Ada Lovelace. So with what we've seen so far, we've seen the io.println. This is a method in Java that allows us to output text to the terminal. In particular, I'm going to output the text Ada Lovelace and save, and then let me run it. Compile and run. I do want to mention that this is not going to run yet. If I were to type Java printing.java, I'm attempting to compile and run this file. It's not going to run yet because we need to be in the correct directory. Our terminal is currently working in examples. So you could go into, you could cd deeper into the practice problems. So cd. Oh, a quick thing I wanted to mention. I did put a space in between this directory. It's gonna make the string representation a little harder. So I'll talk about that in a bit. But if you want to go ahead and get rid of the space over here, let me go ahead and rename this. Let me just call it practice_problems. This will make sense in a bit. But basically, I'm putting an underscore in it, so we can treat this as one thing. Okay, cool. So I just renamed it. Now we can go ahead and cd into practice_problems. So cd, just change directory, enter, and there we go. Now we're inside of it, and we should be able to compile and run. So Java space printing.java. Running out of space here. And enter. And there we go. It outputted Ada Lovelace, meaning we successfully did this exercise over here. Yeah, so I was basically showing this online content. It consists of readings and interactive exercises. So this is a really good content for labs, in my opinion. If that doesn't work out for you, there are other resources too. You don't have to use the one I highly suggest, but you can use other ones like W3 Schools. This is a secondary resource as well, and there's some textbooks as well. These textbooks, I believe they have practice problems in there as well, which would be useful for this class. Okay, so yeah, we just talked about the labs. If you want to take a look at it, it is published in the assignments. Lab week 1. Lab week 1. This is like a reflection activity where you want to reflect, list, and describe what you did for the week. And the lab can consist of any of these activities. There's a lot of things you can do. The reason why this lab is kind of free form is so folks can learn with their own style. Some folks don't do well reading textbooks. Some folks don't, some folks do better doing certain things. Yeah, please describe what you did, and if you want to include links, like maybe you use some sort of source from another place, please let me know with a link. It's kind of like citing a source. Okay. Finally, there is another assignment. This is Project 0. We'll talk about this on Wednesday. You should have enough to get this done by then. Okay. So that's about it for today. Okay. I hope people aren't too overloaded. I feel like people might have gotten a little overloaded on this part of today. the differences between JDK 25 and then before it. But it is backwards compatible, so if you're reading old material, it will still work in the. It should still work in this new one. We'll see both styles, by the way. Currently, we're going to see this style. In the future, after spring break, we're going to see this style. This style is a little more modular, and it allows for a little more flexibility. So yeah, we'll talk about this later. But yeah, that's it for today. Let's summarize what we did, and then we'll end. We started off by introducing computer. Oh wait, no, I already. Oh yeah, I already. keep Yeah, I talked about this earlier. But yeah, we just did all of this, and on Wednesday we're going to jump into some fundamentals. So the fundamentals, this was actually planned for next week. Fundamentals was planned for next week. This is going to, I'm going to shift the schedule a bit. So fundamentals will be on Wednesday. And that's going to consist of a few more readings. So yeah, so stick around for that. All right, that's it for today. Feel free to reach out. I'd be happy to meet folks who are excited, and maybe please use a discussion forum if you're having any technical issues as well. All right, that's about it for today. Have a great day, folks. See you all soon.